right, so today we're going to talk about radical equations. The past, I don't know how many weeks we've been in school, there was no equal sign. Those were expressions. Now we're going to talk about what we do when we have an equation. So, radical equations, an equation that has a variable in a, oh my god, my brain. A radical equation, an equation that has a variable in a radical or has a variable in the exponent. So let's talk about which ones are and which ones are not radicals. So if we look at A, B, C, and D, we got to look and see which ones are. So letter A, do we have a radical equation? Do we have some kind of radical equaling something? Yes. What about the second one? Yes. There's my radical. And if you like to highlight things, this is where you would highlight. This is why. What about this next one? Now, here's a good question. Technically, what is 2 over? 1. Yes, it's not a radical, but it has an exponent that can be written in some kind of way. So it is going to be a radical equation. And I'll explain why when we look at an example that does not have a radical equation in it. What about this next one?
No.
Yeah, why? What does this 2/3 really mean when we talked about that last week? Yeah? Yeah, so this technically means the square root of x plus 3 all cubed. So yes, it is technically a radical. Okay, so you want to look for both of those. These we're going to be doing tomorrow, these we'll be doing today. So let's talk about one that might not be a radical. Something like this. If I had 5 to the x over 2, this would not be a radical because of this x in the exponent. That's actually an exponential function, which we'll get to later this year. Okay, that would be not one. So let's talk about steps to solve the radical equation. So first we need to figure out is it radical or not, and then we move on. Then we're going to isolate the variable, like we always do when we solve. But we want to make sure we isolate the radical this time. That's going to help us determine if we have extraneous solutions or not too, which we'll get to in a second here. Then we're going to raise each side of the equation to the same power, which is technically your index of the radical, to eliminate it. Then we have to check if we have extraneous solutions. Why do we have to check and see if there's something extraneous when we solve, when we're working with radicals? What can't we have in a radical? What'd you say? Yes, I cannot have negatives inside of a radical. Would that be true for even or odd radicals? Can we have the square root of the cube root of negative 27? What would be the cube root of negative 27, for example? What times what times what would get me 27? That's the same number. Yeah, negative 3. So I can have negatives under that radical. So which ones can we not, even or odd? Even, good. So we cannot have negative numbers when we're working with a radical. Just kind of a side note for you, for extraneous. So once you find your answer, you must go back and look when you isolated the radical. Is it going to work out? So let's do some examples and see how you do. So the first question, is it a radical? Yes. Second question, we have to isolate it. Is this isolated? Is the radical all alone? Yes, so we can already move on. So I like to highlight when the radical is going to be alone. How would I get rid of a square root? What's the inverse? Not multiply by 2, but what'd you say?
Square it.
You square it. Very good.
Multiply it by itself.
Multiply it by itself. There you go. Whenever you're trying to get rid of a radical, you have to do the power with the index inside, which the index of the situation is 2. So all I am left with is x plus 6 equals what number? 9. Then we're pretty straightforward here when I do the both sides. Subtract 6. Very good. And I get what number? 3. Okay? Try the next one. Try B with your group, please. Okay? Same type of question here. flying through this. When you're done and when you're done only, check up on the board. There's one more? That sounds like, wait. Oh, yay. Okay, you can check your answers. If you're ever in a situation where, you're on an SAT or any situation where you have multiple choice, you could take the solutions and plug it in and see which one works. When you plug 26 in, you will see that it does work and get you 11. Okay, let's take a look at the next one. Okay, it's just a little bit different. Here is my radical. My goal is to isolate it. It's not isolated yet. What must I do first? Add 2. So now I have the square root of 6 minus 3x equals 2. Now is it isolated? Is it all by itself? Yeah, now I can take what? Now what can I do? Yeah, I can square it. You can't do that until it's isolated. If you do, you're going to cause yourself a lot of problems here. You're going to take way too much time to do these problems. So we're going to square both sides and take it from here. Ask questions if you need it. Gosh, you guys are flying. When you're done and when you're done only, take a look up. But you can leave it as a fraction. You don't have to try to figure out what the decimal is. Just be careful with your negative signs. Okay. Same situation here, but now what is our index? 3. Okay, so when I actually have to raise it to a power, what power am I going to raise it to now? Yeah, to the 3rd. So, again, is it isolated? Because that's what we have to make sure first. No, what must I do to both sides? Yeah. So now I have the cube root of x minus 5 equals negative 2. Again, what now am I going to raise both sides to what power? 3. Very good. Take it from here. Looking around, you guys are flying through this, but be careful with your negatives. Here's why. Kind of what we talked about earlier. Negative 2 times negative 2 is positive 4, but then when you multiply it again by a negative 2, we're getting a negative 8. Some of you have 8 here. Be careful when you use your calculator. You have to put it in parentheses in order for it to work correctly. Do you have any questions up to this point? Pretty straightforward, right? Okay, this next part, however, can get a little bit challenging because now we have variables on both sides. And this is when extraneous solutions can happen. Most of the time, it's going to happen when there's variables on both sides of the equation. So when we look at this, something I want you to write on top of here, a little note for yourself, is I want you to check, when you check your answers, check when the radical is isolated. Okay, if you check right away all at the top, sometimes here, like for F, it's not isolated, so you're really not going to be able to see it right away. So what I'm going to do is I'm going to star it when I'm going through this, so that's where I want you to check it. You have to check, because some of them may not be valid. They might be extraneous when you work with these. Okay, here we go. The question is it isolated first? Yes, it is. So now what do I do to both sides? Yeah, I square it. Now this is not as pretty as the other ones, because now, again, we can't just distribute that 2 in. We actually have to distribute it in. But I have x plus 10 equals now my x minus 2 times x minus 2. Because when something's squared, you multiply it by itself. Here's where we have to distribute. All right, here we go. Gonna rewrite my x plus 10 down. X times x. X times negative 2. Good. Negative 2 times x again. And my final negative 2 times negative 2. Good. Positive 4. So here's where we are. Do you have any questions on how we did any part of that? Okay. Now, again, the goal is going to be to solve for x. Now, remember last semester we told you that factoring was uber important, which means super important. It's coming back a little bit this chapter, not so much, only the easier ones. Okay, so let's first, though, combine like terms. When I do that, what happens in the middle? Ooh, my gosh. What do I get inside the middle now? Yeah, negative 4x and then plus 4. Now, here's that situation where I have three terms. I have an x squared, I have an x, and then I have a constant. When that happens, you have to get everything to one side and factor. So whenever you have that situation where you have three terms, you have to set it equal to 0 and factor like we've done in the past. So what I'm going to do is I'm going to move the x over and I'm going to move the 10. Again, because the goal is to get 0 on one side. Make sure you put it under the correct spots where they're like terms, because these are going to cancel and I'm left with 0. Negative 4x minus x. Yeah, negative 5x. I ask you that because sometimes when we work with negatives, we get a little confused on it. What's 4 minus 10? Negative 6. Now here's where you might want to go off to the side, or if you know right away, great. You're asking yourself what multiplies the negative 6 and adds to negative 5? What multiplies the negative 6 and adds to negative 5? Yeah, we got negative x minus 6 and what? X plus 1. Very good. So if you want to go ahead and go off to the side, if you forgot how to factor, you're asking yourself what multiplies the negative 6 and adds the negative 5, which was negative 6 and 1. Well, now this is pretty straightforward, so we're just going to set each one of them equal to 0. And we're going to solve. What do you get for the first one here? X equals what number? And then x equals what number for the second one? Very good. Now, here is where it's super important that you go back and you check your answers. And put a little star on this spot right here, because that's where the variables, that's where the radical is isolated. It's not always going to be the case where it's where we start. When I plug in 6 here, 6 minus 2 is what? 4. Can a square root produce a 4? A positive number, yes. Now when I plug in negative 1, negative 1 minus 2 is? Can a square root ever produce a negative number? No. So this one is extraneous, and you have to cross it out. It does not work. And if you want to put a note to yourself, this is what I did. Okay, when you plug it in, a square root is never going to equal negative 3. That's kind of how I checked that. When I plug it in, where it's isolated, a square root is never going to equal negative 3. Can't. If it was a cube root, I'd say yes, but it's not in this situation. So 6 is my final answer. Okay, so this next one, it's not isolated yet, but I feel like you can do it, so go ahead and try to work through that one with your partner or your group. Okay, so isolate it first. Be careful with that negative that's out in front. getting stuck on this one part. So at least let me walk you through how you isolate the variable, just because it's a little tricky with that negative out in front. And I don't want you to do something for no reason if you're getting stuck. So when I isolate the variable, that means, the radical, just a highlighted portion. That means that this -5 needs to go away and the negative in order for it to be isolated. So I have to add 5 to both sides. Now you cannot add 5 to x because they're not like terms. Now here's the spot where a lot of people got stuck on as I walked around. You have to get rid of the negative before you can do anything else. If you don't, it's going to lead to errors at the end. With that said, there goes my pen. Wouldn't be a day without me dropping something. Okay, that changes all of the signs. It's all it does. I think from here, you can now take it. So go ahead. Make sure that you're doing that correct now. That negative is what was getting people. You're going to have -5 and x minus 5x, which is 0. Try not to skip too many steps. Okay, 6 and 3 are going to get 3. That's what's going on right there. Yes. So after you combine the terms of the 7, you're going to subtract 1x from whatever you got. Yeah? That's a pretty great one. When you're done and when you're done only, you can start taking a look up and see if your work is correct. Okay, you can look and see if your distributing was at least correct in this part. And then I'm going to keep going. So when you're done, look up. Ooh, I totally did that wrong. Plus 18. Okay, so if you got to here, great. Some of you had this part wrong. Make sure you're subtracting the right ones. Okay, when you subtract the x over, that makes a -11x. Negative and negative. They're technically going to be adding them. If I owe you $10 and I borrowed one more, I now owe you 11. Okay, so then when I subtract 25 and -7, I get 18. What two numbers multiply to 18 but also add to -11? 9 and 2. Now, are they positive or negative? Negative. Okay, so now I'm going to go ahead and solve. I get x equals 9 and x equals 2. Here's where I have to go back to where the radical was isolated. So the radical was not isolated until this step. That's kind of why I put a star there. If I take 9 and I subtract 5 from it, are we good? Am I going to get a positive number? Yeah, because 9 minus 5 is 4. However, if I take 2 and I subtract 5, what do I get? Can I get a negative when I have a radical? No. So Cross that one out, and 9 is your answer. Okay? All right, so what we're going to do for the rest of the period is pretty straightforward, but we're going to go on Desmos. It's very short, but here's why we're going to go on Desmos, because you have an exam that's on Thursday, and this is kind of like a little bit of what we just did, but also a review of the topics that we've done the past couple weeks. This will help us see where you are for the exam, and if we need to review any topics before we go into it. So please have your Chromebooks out and go on Desmos, please.
Ladies and gentlemen, part of the test is non-calculator. So if the question on there says calculator allowed or it says non-calculator, make sure you follow the directions because those are going to be similar to the questions on the test.
These questions pretty much mirror the exam. So they're going to kind of prep you for it. Could you answer these correctly or not? Hold on, let me get this up. Okay. All right, here you go. Just give it a second. There we go. 6YJGRs.